Assalamualaikum warahmatullahi and hi, my name is Loman Rahim Mustaqaman. Metric number AW180175. My part is explaining the introduction in our report. Firstly, FM in real life. Feminine element software is an initial tool for the most bright design engineer at the cost of most industrial FE software had better in international. The commercial FE software used by many engineering firms will provide you more computer output than you could read in a month or more than you can understand in a year. So the main purpose of this analysis is to develop a stable, reliable examination methodology, especially a method that enhancing feminine element bridge structure that can progressively progress the static ideas. The truss elements are usually utilized in the investigation of the truss structure. Thus, this study explains the increasing of interaction structure, including of a software package with a ANSYS 14.0 that would allow bridge design engineer to easily design bridge. The theory rules is simple. The design structure is designed with a top and bottom cross that triangular with a diagonal with a middle with an intention of each component hold a purely axis load. There are four categories of truss bridge design, which are variant, thread, hover, and K truss. Those are basically triangle design and typically integration of compression and tension. Next, the design. So, a strong bridge depends on how strong structural battery of the bridge. So, we assume that by ASTM A36 steel plate with the most widely used hot wheel rolled steel product to produce a good material property and cost less in as it ultimate tensile strength range of 58,000 to 79,800 power psi.
Assalamu alaikum, and my name is Nick Abdul Benu Omanasir, and I'm going to tell you about the procedures that have been done in this experiment. As for the type of models that have been referred, we decided to choose one of the truss bridge. The truss bridge has been named as Warren Truss Bridge. The reason why we choose this bridge is because due to its requirements of materials and also because it is easily to be constructed. As for the type of materials that we used in this bridge, we decided to use steel ASTM A36 based on the research that have been done by us. The reason why we choose the type of steels is because due to the ultimate tensile stress, which is ranged from the 58,000 to 79,800 per square inch. It also can elongate to around 20% of its original stress, which shows that it has excellent impact stress at room temperature. As for the designs of the members, we decided to use circle round center cross-sectional area. It is because circle is known to have high tolerance in order to expand the force that be applied on it evenly. Next, the type of supports that we use in this bridge is pin support. The reason why we use this support is because it has ability to stop for a moment of the applied force in other direction. Next, procedure used by FEM spreadsheet. First, users input the node geometry and loads and member connectivity of properties and uniform loading. Second, spreadsheets calculate the fits and moment and shears for each member due to its applied member loads. Third, spreadsheet calculate the local member stiffness metric for each member. Fourth, spreadsheets calculate the coordinate transformation metrics for each members. 5. Transform local member stiffness metric into global stiffness component for each members. 6. Assembles the global metric K by summing all the local values for each respective degree of freedom. 7. Inverts the global stiffness metric using SL minus inverse functions or adding function minimum verse dot est. 8. Assemble the global loading vector F from nodes loads and FEM values from steps to evolve. 9. Calculate the global deflection from D equal to K minus 1 times by F. And the last but not least, calculate the member end force using global deflection F and transform local stiffness.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Kasha Irfan bin Marahimi. So for my part, I'm going to present to you about the data that we obtained. So as stated earlier, we use two types of transport that passing by our bridge, which are the car and the lorry. So we will start by the car first. As you can see in the screen, we use a pin support with a 500,000 Newton input force for Y and X axis for node 1 and node 16. So we will get the support reaction and output deflection. For the support reaction, we obtain the data for Y and X axis for node 1 and node 16. And for the output deflection, we obtain the data for each node, as you can see in the screen. Moving on to the output member force, which are including the axial force, shear force, and the moment in I and J. For the first table is for the I part, and for the second table for the J part, as you can see in the screen. Also, we obtain the matrices for each member. So this is the matrices for each member for the car. Moving on to the lorry. So as you can see in the screen, we also use the same type of support, which are the pin support, which same input force, 500,000 for node 1 and node 16. So we will obtain the support reaction and output deflection. Also same like the previous, we got the support reaction in Y and X axis for node 1 and node 16, and output deflections, we got the result for each node 1 until 16. And moving on to the output member force, also including the axial force, shear force, and moment in I and J. For the first table is for the I part, and for the second table for the J part, as you can see in the screen. Also, we obtain the matrices for each member, as you can see in the screen. So for further explanation, we already discussed it in our report. So that's all for my part. Thank you very much.
Hi, my name is Muhammad Shami bin Sanam, and today I will be presenting the simulation of our thrust. The simulation is to simulate the real life situation of the bridge under the load. First, let's see the car. The car is weighing around 1.2 tons. Notice that the force exerted on the bridge is around 3 members and the load is 20%. Next, let's see the differences between the lorry and the car. Okay. The lorry is weighing around 4 tons. Notice that the force exerted on the bridge is 4 members, and the colors of the bridge is way brighter than the colors of from the car. This means that the force exerted from the lorry is way higher than the car, around 32.8% load. In conclusion, the higher the force is more likely to have for the bridge to fail.
Assalamualaikum and hi. My name is Muhammad Hamizah Mizarani, and now I will present the conclusion for our project. To get the result from the data, we are using finite element method in Excel spreadsheet. In this result, we have two kinds of data, which is the first one we using car as the load, and the second one we using the lorry as the load. As the result, the value of support reaction for both of the load is negative. This negative value is due to the Newton's third law. Next, the result of the output deflection for lorry is different with the car, as there are different load between them. In other words, the larger we apply force in beam or member, the higher the value of the output deflection.